go. Everybody say hi, Michelle and Abigail. Hi. 5A, the excursion section. I'm going to write the assignment at the top of this thing here, page 376. 2 through 32, the evens. This looks like a long assignment, but I just told you most of these are pretty swift. They're pretty short and fast. Okay, it's like switching bases. So there's that. Evens for all those sections. All right. It does seem like a lot, yeah.
I put a little sticker on here. Why do we not have homework tomorrow?
Please.
You probably won't. Unless we don't get done with this section.
Tomorrow, Thursday, Friday.
And
We'll see.
Saturday.
We'll see.
Saturday.
Well, if we have homework tonight, then poop on you boys, right?
Yeah.
We can have homework tonight, but not tomorrow because we like the girls better than the boys.
Yeah.
Right?
Let's just not have homework on Wednesday.
All right. Anyway, all right. So there's the homework assignment. This first box is just switching from logs to exponents. Okay. So here's your log box. This is your log column, and here's your exponents. Okay. We did this a lot on Friday, just switching back and forth between the two. Okay. So this is how I'm teaching my algebra kids. They're doing this right now. Okay. The base of the log is the number that's in the basement, right? So this guy's base is b. So when you are trying to find the base of the exponent, it's just the basement number of the log. Okay. Here's the basement number b. Here's the base of your exponent. Those two numbers stay in the same spot. The basement number and the base are still the same. Okay. The second two numbers switch. So b to the u power equals v. That's how he's written over here. Okay, and it's just going back and forth between the two. The basement number on the second one is 3. 3 to the fourth power equals 81. That's how they have it written over here. Okay, we know how to switch back and forth between the two, right? Basement number here is 4, so 4 to the third power equals 64. That's how they have it written over here. Basement number is 125. 125 to the 1/3 power equals 5. Okay, let's talk about him for just a second. What does the 1/3 power actually mean? The cubic root, right? So this is really saying the cubic root of 125 equals 5, right? What do you take times itself? 3 times to get 125, it's 5, right? That's what that means. That's what the 1/3 power means, right? Okay, and this next one, ooh, this is ugly stuff. Is this an 8? 8 to the negative 2/3 power equals 1/4, okay? That's kind of an ugly thing, but that's the cubic root. This is really saying the cubic root of 8 squared. And then to the negative power, which flips it to be a fraction, is 1/4. Okay.
Okay.
Something of that nature.
Just wait.
Something of that power. Of that. Okay. So whatever. Don't get bogged down by those exponents. We'll talk about those later. Okay. So just flipping them around for the most part. Okay. ABC, these first couple, without using a calculator, find each value. They want to know what log base 2 of 16 is. And in order to switch it to an exponential function, okay, which is what we're going to do first, we have to have 3 pieces.
Equals x.
So let's say equals x. Did we talk about that on Friday? I get you guys confused with my algebra class now because they're kind of doing the same thing, but not quite as hard, right?
Think so.
Did we say equals x before?
think
Okay, so we need that third piece. We need to know what he's equal to, so let's just put x or some variable in there that we can solve. Now we want to rearrange him and make him an exponential function. So the basement number is 2 to the x power equals 16. And all I have to do to solve for x is say, how many times do I take 2 times itself to get 16? X is 4. Okay? So when they ask for log base 2 of 16, log base 2 of 16 is 4, right? Make sense? Okay. All right, B equals x. That's the first step. We need that third piece, and then we have to flip him around and make him an exponential function. Okay, so the basement number is 1/3. Okay, to the x power. You don't have to put parentheses, but I'm going to do parentheses just so that you don't get confused with the 1 and the 3. Okay, 1/3 to the x power equals 9. All right, now ignore the fraction. Ignore the fraction for now. Let's just talk about the 3. How do I go from 3 to 9?
3.
Times 3, so it's squared, right? 3 squared gives you 9. So x should be 2, right? Except, how do I switch it from a fraction or switch it from bottom to top? You make it a negative, okay? People a lot of times get confused. They think it should be 1/2 instead. That's going to be a square root. Negatives are what switches it from fraction to non-fraction. The 1/2 power is what makes it a square root or a cubic root, that type of thing, okay? So just think about moving the 3 to a 9 squares it, but it has to be a -2 now because I'm making it into a fraction. So -2. Does that make sense? Yeah. Good. Okay. So don't get bogged down with the fractions. All right. Next one equals x. 5 to the x power equals -25. All right. How many times do you take 5 times itself to get 25? 2, right? So x should be 2, except how do you get -25?
-2. No.
But -2, so 5 to the -2 power would be 1/25.
It's a half.
Okay, it's a half. 5 to the 1/2 power would be the square root of 5. How do you get -25?
-1/2.
Uh-uh.
Then that makes no sense.
There's a reason for that.
Oh.
You can't get negative numbers. You can't have your x's be negative numbers. Or you can't have your, I guess, y values be negative numbers. Okay? So, there will come a time, maybe, I don't know if they do that to you in your homework assignment, but there may come a time if it smells fishy and looks like a fish and smells like a fish, it's probably a fish and there's no solutions, right? Yeah. Okay, sure. All right, you guys don't know. You're too young. Okay. Moving on. Solve each equation for x. Okay. Solve each equation for x. Solving log equations. All right. Now.
It's the same thing.
Kind of, except.
Except we have 3 parts now. They give us 3 parts.
Yeah, they did give you the 3 parts. So let's switch it around and let's make it an exponential function. Okay. We'll see what that gets us, right? 5 is my basement number, so it becomes my base. 5 to the 3rd power equals, oh, that's pretty easy. I can just plug it in, right? What's 5 to the 3rd power? You can do that in your head. 5 times 5 times 5? 125, right? It would be 25 times 5, 125. That's it, right? Okay. Next, make him an exponential function, exp. 6 to the x power equals 1. Okay, this one's a little tricky.
No.
Caleb's got it. Anything to the 0 power is 1, right? 6 to the 0. So really, it does not matter what number. Okay, check this out. It really does not matter what number is right here. If this number is 1, this number's got to be 0, right? Any base, if you have 1 next to it, anything to the 0 power is 1, right? Anything. So that number is going to be 0 always. All right, next one. C. Oh, boy. 1/6 to the x power equals -3. Okay? Now, so we're sitting here like, how do you go from 6 to 3? How do you go from 6 to 3? But it's a -3, so we don't really care anyway. You can't get a -3, right? So, no solutions. We don't even care that 6 and 3 are a hard combination to do, right? Okay? No, oh, sorry. Don't put not equals 0. X is equal to no solutions, or you can just put no solutions. I don't know why I slashed the wrong thing. No solutions. You can't get -3.
Is the next one 1?
Okay? This one, 6 to the x power equals 6. Is the next one 1? Yes, it is. Okay? Happy with that?
Wow.
Good, good? Yep. All right. Beautiful. Okay. You guys want a little trick to check your answer? Sure. On your calculator, you guys have the fancy spancy calculators, right? Yeah. On your calculator, you have change of base things, and I usually don't teach you this until like after we're done with this chapter. But don't use this information to cheat. Use this information to check your answer. Okay? Here you go. I'm going to show you on your calculator. Let me pull your calculator up.
I mean, when you tell us that.
To check your answer. So you can check your answer. So don't use this to cheat, because on the test you better believe that I'm going to use X's and Y's and stuff that you can't use your calculator to cheat with, right? So you do have to know the rules. But I'm doing this so that on your homework assignment you can check your answer and such, right? Okay? On your calculator, you turn them on. If I hit the log button, like just this guy right here, that log button, and he doesn't have a base, what do you assume the base is? 10, right? Okay, so I want to change the base, because in this problem over here, In this problem right here, the log base is 6, right? Okay, so I want to type in log base 6. So go to, I'm going to clear them out, go to the math button, and it's on that main screen. All you have to do is scroll down, and it's right below the summation that we've used before where it says log base. Do you see that? Okay, hit enter, and then you can change that 6 and 6, right?
Wait, what number is that?
I'm doing part D.
I'm pretty sure you showed this.
Okay, and you hit enter, and it's 1, right?
Go back to
You can
the
change
math.
this. The math button.
Yeah.
So hit math,
Down.
just scroll down.
And what number is that?
It is A.
Okay.
It's A. It's right below summation. Okay.
Alpha math. Pretty. These are ugly. That looks terrible, right?
Oh,
You don't need alpha. It's A, right? If you don't want to.
Oh, yes. I see your A. Yep, you're right.
Yeah.
Right. I get it. Okay, so you can change the base on your calculator. Do not use that to cheat. Use that to check your answer, because on the test, I will make sure that you know how to switch them around, right? Because I'll use X's and Y's instead of actual numbers, so be careful of that, all right? But I'm showing that now so you can check. Okay, moving on. Logs to other bases. Here we go. Solving log equations. I'm just going to go to example 3. We do, in fact, have 3 pieces, okay? The x minus 1 is 1 unit as a whole, hence the parentheses, okay? So we still have 3 pieces. We want to switch him to be an exponential function. All right, what are you going to do? 3 to the 4th power equals x minus 1, okay? 3 to the 4th power, you guys do 4th powers like the right way? If you're taking 3 to the 4th power, you have 3 times 3 times 3 times 3 4 times. Ready? Here's the wrong way. Everybody watch. 3 times 3 is 9. Do not take 9 times 3 again, which is 27, and then 27 times 3. Take these 3 together, and then you just take 9 times 9, which is 81. That's how you do 4s, really fast. Does that make sense?
Yes.
If you do these 2, which is 9 times 3, that's 27. 27 times 3, now I'm lost, right? Do the 3's over here, the 3's over here. Each one is 9. 9 times 9 is 81. That's how you do 4s. That's how you do 4s really fast. That's how you save time on the ACT.
It's a family tree.
Okay? It's a tree. Yeah, you're right.
Wait, I have a
So,
question for you.
81 equals x minus 1. Okay, hold on. Add 1. 82. Okay? You can plug that back into your calculator to check the answer, because now you know how to change the base to 3 if you want. And there's that. What's your question?
Does it bug you that, like, your pencil marks are thicker and thinner? Because you can change it to
Yeah,
one
yeah.
size.
You can change it to one size. What are you talking about?
Yeah. So click on your purple up there at the
Yeah.
top.
Yeah, right here. Yeah, I change them sometimes.
And then, no.
No, but like she's talking about like.
Oh,
Yeah,
just switching
that.
like that?
And then it's
Scroll
just
over.
one. It's
You
not
can have
thick
it
and
be
thin.
like dotted or dashed.
What? Oh my heavens! I didn't know that. I kind of like though that he does like thick and thin. I kind of like that because sometimes if I'm trying to write really small, he'll only write like really big. If I don't know. Anyway,
What?
I'm just gonna leave him. I'm used to it now. I'm just gonna leave it. But that is kind of cool. All right, ready? Logs of other bases.
No.
Okay. Here is the product quotient power law. Okay, these 3 things we've talked about before, right? Multiply. Here you're multiplying. Multiply means add. Okay, so take a look at this. When you have one log, and you're multiplying in between them, it becomes 2 logs when you're adding in between them, yeah? So 1 becomes 2, but in order to do that, multiply becomes add. Does that make sense?
What did you just
1 log becomes 2 over here, but in order to do that, multiply becomes add, yeah?
Yes.
Okay? 1 log over here becomes 2 logs, but in order to separate them, you have to change from divide to subtract, right? Okay? All right? And then here, the rule was if you have an exponent and you have a log in front, that number can just come down in front, right? So like the k comes here in front. That's kind of our favorite rule because then we can just really do interesting things with the thing. Okay? Good? Interesting things with the thing. All right. Moving on. Ready? Okay. Look at the stuff that we're given. We are given log base 7 of 2. We are given log base 7 of 3. And we're given log base 7 of 5. We will use some of those things, maybe not all of those things, when we are trying to find log base 7 of 10. So let's do that first. Log base 7 of 10. How can I come up with 10 if I know 2, 3, and 5? 2 and 5. Okay, so I'm going to do log base 7 of 2 times 5. I'm going to write it like that.
If you add them all together,
Okay?
it's 10.
No, we don't want to add them all together. We want to come up with, because if it's one log, this is where people get confused. If it's one log, it has to be multiply on the inside. Does that make sense? To become 2 logs that you're adding. So it has to be multiply on the inside. Right? These two can come up, can separate into 2 different pieces. Log base 7 of 2, log base 7 of 5, but you have to add in between them, right? Okay? So log base 7 of 2 is this number here. Log base 7 of 5 is this number here. If you add them together, you get something. 1.833. It was like 0.3562 plus 0.8271.
Can you scoot it over?
I can. Okay, good? Good so far? Yes?
Yeah, understand.
All right, next one we have log base 7 of 2.5. How do I get 2.5?
5 divided by 2.
Yeah, 2.5 as a fraction is 5 over 2. Okay, 5 over 2. Okay, so I am dividing inside of the one log, and if I separate those into pieces, log base 7 of 5. Does it matter which one you do first?
No.
Yeah, it does.
When you are multiplying, it doesn't matter if I take 5 times 2 versus 2 times 5, but in this case, I have to have the 5 first, right? Because when you're subtracting, it does matter what order you subtract them in. Does that make sense? Okay. Log base 7 of 5 is 0.8271 minus 0.3562. And that is 4 something. 0.4709. Yeah? 4709. Okay, now's the tricky one. Log base 7 of 48. How can I make 48? I'm going to have to multiply things together, right? I'm going to have to. Well, what can you multiply together to get 48? I don't even know.
Well, what I did is I took the log base 7 of 5 times itself 4 times, and then I subtracted the 2.
Subtracted what, too?
Okay, so you took log base 7 of what? 5 times itself.
Or like, well,
Why don't you
5
just do-
times itself, or 5 to the 4th power, and then
Why do you say 5? Do like
5 to the 4th power.
do like log base 7 to
5 to the 4th power. That would be like 625.
Yeah.
Is that what you're saying?
or I meant like
Log base 5 or log base 7 of 5 times that 4 times. Is that what you're saying?
yeah. Or I don't know. I plugged it into my calculator and it worked. What
What
I
if you
did.
did
But
log base 7 to 2 times 2?
I don't know. Now
That
I'm
would make it
confused.
4 plus
I don't know.
the 2 and 3.
So do log base 7
Which would be
4
6.
times and then subtract the log base 7 of 2. That's what Al is saying.
I have no idea.
So like
You're hurting my brain.
log base 7 of 5 to the what?
Ellie, I would not write this down.
Don't write it down yet. Don't write down yet.
I'm not.
Because we got to figure out what 40, how do we get 48? Oh, 48 is 16 times 3.
Or you could just take 2 times however many times.
I like that idea.
You could take 2 by 24 times.
What? So 2 times 2 times, what is it?
2 24 times.
No. Oh. No. But that wouldn't work. That's 2 times 24. Not 2 to the 24th power. Yeah, I totally get it. 2 times 2 times 2, this is 8. Times 2, that would be that's 16 times 3. Check that out. Take 2 times 2 times 2 times 2 times 3.
This is how much
2 times 2 times 2 times 3.
Is that 48?
Yeah.
Yeah, right? Because this is 4, that's 4, 16 times 3 is 48. We could do that way. Okay, but hold on. Before we start doing all those 2's and junk, right? Okay, let's write this instead as log. Let's write this as log base 7 of 2 to the 4th power times 3. Okay, this is going to make it go a little faster. If we write it as 2 to the 4th power.
You should have that up there.
What? Where?
equals.
Okay, equals.
No. Log of 748
Yeah, that's what I was
equals.
trying to figure
Oh,
out.
sure, equals. Right.
And then log
right.
of 7.
Yeah,
And
sure.
then you're gonna have a lot more room if you.
Okay, that's fine. I'll go down to the next one. Okay, now, these two multiply means add. So log base 7 of 2 to the 4th power plus log base 7 of 3. Right?
Yep.
Okay, now, before I start plugging my numbers and such in, what's one more thing I can do?
Don't ask.
2 to the 4th power.
To the 4th power, that 4 can come down in front, right?
Yeah.
So 4 times log base 7 of 2 plus log base 7 of 3. Does that make sense? And now all I have to do is take this guy. Log base 7 of 2 is, I don't know, 0.3562. And plus log base 7 of 3 is 0.5646. Okay, so take 4 times this number and add it to that number. Does that make sense?
Yeah.
Okay. Now, we could have done another combination. You could have done a combination where you were like dividing and subtracting or whatever. And so my point is, like, Allie wanted to do it a different way and she got it to work out. That's fine. Do it that way. Okay? All right? If there's multiple combinations that you could have done. Okay, what'd you get? Like 0.7 something or 0.6 something?
I got 1.9894.
After I'm sorry, you're adding. I was subtracting in my head. 1 point what? 98? 9894. There we go.
I got that.
Okay, perfect. Does that make sense? So you could have done those multiple ways. Just whatever way you can get to work is great. Is this our last? Nope, we've got a couple more examples. Okay. Simplify and write each expression as a single log. Okay. How many pieces do you have going on? Technically 1, 2, 3 right there. Okay. All right, look at what's separating them. We have a plus here, which means I'm going to take those guys and put them together, and that's going to be a multiply. Okay, this one's minus, so I'm going to put those together, and I'm going to divide. Okay, so when I have, do you want to try to put these all together at one shot? Like, okay,
No, I do not.
it's probably easier to put them all together at one shot, and then we'll simplify some stuff. Okay, so we're going to have stuff that we're multiplying on the top and stuff that goes onto the bottom, right?
Oh, no, I'll get out.
Okay.
I'm busy.
So we want to multiply these two guys together, the x plus 2 and the y, right? So how do you want to write that?
X
plus 2.
I like putting the y in front, like Ellie said. I like putting the y because he's just one piece, so we can do like this, right? And then on the bottom, x squared minus 4. Oh, they were not very nice. Simplify and write each answer. Blah, blah, blah. You guys see something going on here?
No, I do not.
Anytime I see x squared minus 4, I'm like, ding, ding, ding. That's something interesting. That's something special, right?
No.
X squared minus 4 is a
I don't know.
Difference of squares.
difference of squares. X plus 2x minus 2, that's what a difference of squares breaks down
Are
into.
we breaking it down?
We're gonna, yeah. Because the answer's really super nice then.
Pretty.
Do you see what happens? This guy and this guy cross out. So all you have is log base 3 of y over x minus 2, and that's it. He's beautiful now. He's beautiful. What's up?
You said they weren't very nice.
Okay, makes sense? Is that good? Is that okay?
Yep.
Yeah?
Yeah.
All right. Beautiful. I like it a lot.
Great.
Woo! Sure.
How much do we make off of each of these?
That I'm not real sure. I can look it up and let you know.
I know very much. Just like 3 of them are $2.
What?
Like the option A, B, and C are $2.
Well, yeah,
D and E is
but
5. That's 3.
we buy these in whole dozens and then package them together. So like a dozen cookies cost like $3 or whatever. So if you sell 2 for $2, you're making you're making $12 off of a thing that was $3 to start with. Does that make sense?
Yeah.
So
Okay.
yeah, that makes sense.
So it's gonna be divided like.
Ish. Yep. So anyway, I've got to do that. I've got to look that up and do the math. Okay. All right. So done with that one. That one's good. B. Okay. we have this 3. Do not, when you're trying to do this, do not look at the 3 and look at the log and say minus means divide. Why can't you put those together to divide? The 3 is not a log, so he's just off by himself, okay? So what are some things that we can do here?
Good question.
That's a good question.
You can't put the 3 up, can you?
Nope, you can't put the 3 up because the 3 is not right next to the log. Can we what?
Set it equal to x?
Not quite yet. Look at these 2 pieces right here, 125 and x. Those are multiply. So let's break them apart. And break them apart means adding.
Would it be a negative?
Yes, so we got to be careful of that. So log base 5 of 125 plus log base 5 of x, right? Okay, now here's the thing that Indy said be careful of, because would it be minus? Since there's a minus in front of the whole thing, we have to drag that minus through for both of the pieces. So I've got 3 minus that minus log base 5 of x. Does that make sense? The negative's in front of the whole thing, so we've got to apply the negative to everything, okay? Now, the only other thing that we can do is this log base 5 of 125, he doesn't have any variables in him, so we can solve that thing. So let's just go over here off to the side and let's figure out what log base 5 of 125 is, okay? All right, log base 5 of 125. I'm going to say equals x, kind of like we were doing up above. And this says 5 to what power gives me 125? And x equals 3, right? So this thing right here, this is 3. So I've got 3 minus log base 5 of x. So the 3's cancel out. And I have negative log base 5 of x. Okay? Are we okay?
Yeah.
Now, circle that if you get to that point and you call it good and you circle that as your answer. I'll probably count it right, but guess what the book's gonna do?
You want to change it to positive?
They're gonna say log base 5 of x. This negative in front is kind of like saying negative 1, right? Where can that negative 1 go?
By the x.
Up by the x. Okay? What is x to the negative 1 power actually look like? What's negative powers do to him? Flip him. What's the flip of x? 1 over x. This is what they will write it as. Does that make sense?
Yeah.
Okay? If you get to that point and stop here, more power to you. Yeah, that sounds good to me. Okay?
So the book
That-
is going to do this.
The book is going to do the bottom part, the purple part. Okay?
But
That okay?
Is Holly still gonna count me right? Isn't she separate?
Sometimes. Sometimes. I've been doing it lately.
So you'll fill my butt.
You'll be okay. Yep. Okay, good? All right. Couple more. If you are given a problem like this one, log base 8 of 9. Okay?
Throw it away.
Throw it away because we don't like it.
Can't you just plug it into your calculator and call it back?
you can, but you need to know how to convert to a different base. Okay, so check this out. What I would start by doing, if I was solving this, what I would start by doing is say, okay, let's say equals x. Don't write this down. Let's say equals x, okay? Equals x, and I would say 8. I'd flip it around. 8 to what power gives you 9? How many times do I take 8 times itself to get 9? That's where it fails. That's where it falls out, right? 8 to what power gives you 9?
0, 5, 6.
Right. 8 to what power gives you 9? Doesn't work, right? So instead, here's what you can do. You can change everything that is not already a log base of 10. You can change everything to a base of 10. Okay, so check this out. Ready? This is what you're going to do instead. Log base 8 of 9 is equal to, everything can convert to a log base 10, and here's how you do it. It goes into a fraction, okay? And it is log base 10 of something over log base 10 of something. And here's where the numbers go. Ready? Sure. Okay. What's the basement number?
8.
It goes in the basement. Log base 10 of 8 and log base 10 of 9 goes on the top. So if you don't want to change the base, all you have to do on your calculator is log 9 divided by log 8. And that is all. Okay? Log 9 divided by log 8. 1.05 what? 6? 1.056? Sure.
Well, actually, it'd be 7.
Oh, 7. Okay, 1.057. There you go. Okay, now, so that's one way of changing log base. You can also change this to an ln because ln's will do the same thing. So rather than changing it to log base 10, you can change it to ln of something over ln of something because it's just a different base. So it would be ln of 9 over ln of 8, right?
That does not seem legal.
It's totally legal.
It seems too easy.
You could, if you wanted to. I don't know why you would, because your calculator doesn't automatically think in log base 2, but technically log base 2 of 9 over log base 2 of 8 is the same thing. If you wanted to change it to a log base 17 of 9 over log base 17 of 8, that's the same thing as well. So doesn't matter which base you switch it to, as long as you put the top one on top and the bottom one on bottom, you can switch them to any base you want to. Okay, it is totally legal.
Can we book it? Next one.
Can you book it next one?
Last one.
So would we have been able to put log base?
Let's skip this one.
Yes. So we're done?
Okay, sure. Yep, skip that one.
So we don't even need this back sheet.
Right, probably.
Erase it.
Probably. Okay.
Technically, the tree was already cut down, so it was wasted anyway.
There you go.
Okay,
There you go. Okay. Here you go. Yeah, here's one.
All right, there we go. I'm gonna everybody say bye, Abigail and Michelle.